So number 13. Paste that thing there. All right. If the function is 1 to 1, find its inverse. If not, write 1 to 1. So to be a 1 to 1 function, that means you must pass what test? Horizontal and vertical line test. So let's check that first before we do any work to find it. So I'm just going to graph it. That's the easiest way to check eventually. All right, so y equals, and then it's, I got a bunch of stuff from today. Get rid of that. All right. It's the cubed root of, or no, 4x to the third. 4x raised to the third plus 2. And just hitting graph. See what that does. Okay. Looks like it passed the vertical line test pretty easily. Horizontal line test, there's only really one place in question, and it's right there, and it doesn't really ever get flat there. So I think it passes both of those. So that means we're going to have to go ahead and find the inverse. So it does pass both horizontal and vertical line tests. So then when you're finding the inverse, what do inverses swap? Swap x and y. Good. So that's going to be x is equal to 4 y to the third plus 2. Then I got to get y by itself again. So I'm going to subtract 2. That's x minus 2 is equal to 4y cubed. I would divide everybody by 4. Y cubed, x minus 2 over 4. And then opposite of cubing something is to do what? Take the cubed root. And that's our inverse. X minus 2. 4, and that's f inverse of x. Which matches C. Yeah. X minus 2. Yeah, C. Should be the correct answer for 13. How could I verify that graphically? If I could graph that inverse, so I'd get the cube root, math 4, and we'll put parentheses, x minus 2 divided by 4. Hit graph. What line should those reflect across? Does anybody remember? They should reflect across y equals x. And we can see right there that if you drop the blue one across that line, that it's going to match up to the red one. And they're crossing on that y equals x line. So that'd be a way that you could verify that two things are inverses of one another just by looking at the graphs. And they should reflect across the y equals x line. They're inverses. There?
Okay, whenever you say if it's 1 to 1, it means you can take the line.
Passes the vertical line test. It only touches at one spot in any place. And then it also passes the horizontal line test, which it only touches it in one spot.
If it's not, we want to hit it more.
That's right. That's exactly right. Okay? And I don't care to go bounce back and forth. I just don't want to rework problems I've already worked. So if you... Yeah, sure. Number 8. All right, so function composition, what we're dealing with there. And this one, they're nice enough to give you a number that they want you to work out. Okay, so when you got a number there to work out, that just means I want f composed with g of -6. What that means is it means take g of -6, get its answer, and put it into f. Okay, so I'm going to take -6 and put it in here for x. It's going to be 3 times negative 6 squared minus 5 times negative 6 plus 7. So that's 36 times 3, which would be 90 and 18, so 108 plus 30 plus 7. So that's 138 plus 7 be 145. That's g of negative 6. Now I've got to take that number and plug it in for x in f. So f of 145. 2 times 145 minus 5. If you double 145, it'd be 290 minus 5, be 285. Start working it out. If they've got a number in there, that's the only way you want to do it. You don't want to try to do the actual algebra composition of that. Into F. Yeah, that would be a common mistake there. You got to remember when you're doing function composition that this goes in the one closest to it, and then get its answer, and then go into the F. So you kind of work backwards. And then work that out, and then plugged in the negative 6. Should have got the same answer, right? Yeah, that works. A lot more algebra than you have to do, but yeah, absolutely. That one wouldn't be too bad because you just... We did do something like that. We actually found the algebraic composition, and then I said, okay, well, let's find the number value too. So we did something like that too. Not bad. Next.
7.
All right. Same area there. A function difference. All right. Copy that. All right. It's all in following the directions they give you. They're nice enough to give you the formula there for the difference quotient, which just means take that stuff and work it out for this function. So f of x plus h means we're replacing x with x plus h in that function. So that means take this and put it in for x in both places. So that'd be 4 times x plus h squared plus 9 times x plus h. Okay, we're going to work that out. I'm doing it like separate pieces because I think it's easier that way. So when I square that, that's going to be x squared plus 2xh plus h squared. And then I would distribute here. And I'm going to go ahead and distribute the 4. All right. And then it says subtract the original function. Okay. So that's what I'm going to do next. I'm going to subtract h, or f of x, from the x plus h. So subtract 4x squared plus 8xh 4h squared plus 9x plus 9h minus 4x squared plus 9x. And I put that in parentheses on purpose. And then I'm going to go ahead and put over h because that's the last step. I did. That means it's supposed to be 9h right there. There we go. Now, so I'm subtracting this and this cancel each other out. This and this cancel each other out. So that what I'm left with is 8xh 4h squared plus 9h, all divided by h. And I can simplify that by dividing each piece by h. Because what happens to the h's? Yeah, 1 cancels 1. So this one cancels one of those, so it's just an h, and this one cancels that one. So we end up with 8x plus 4h plus 9, which was, that's your choice, 8x plus 4hc. But again, it's one of those exercises in function operation stuff. That's all that really is. The difference quotient. I can count on one hand how many times I've ever had to use a difference quotient. So it's not something you use a ton, but it's something they try to bring out. But it's to practice the function operation stuff. Is the reason we do it in college algebra. There's some use to it in calculus, but not so much in college algebra. All right. Next, 14. Yeah. 14. Oh, yeah, we got a graph there. And they want us. What? Shrink down there, you crazy, don't you? I'm so crazy. All right. So we got a graph, and they want us to find the inverse of that function. So the graph of the f is drawn. Use the graph to find the indicated value. So f inverse of 2. Okay, so that means on the inverse, the 2 is actually what value? It's in the x place, but it should be a y value. So we want to know where is y 2. So I'll just draw myself a little dotted line here. And right there is where y is 2. It should be 4. Okay. You got to remember that it's the inverse. If they ask for f of 2, just regular function f, then they would say, okay, x is 2, find the y value, and you'd go right there. But they ask for f inverse of 2. So you got to remember, inverses swap x and y. So that's a y value on the original function, which is what's wrong. It's a mind bender a little bit because you think, okay, I'm already backwards because they've already given me an inverse thing, but the graph was the original, and you got to think I'm working from the original graph, not the inverses graph. So you got to think, okay, this is a y value. That's the trick to that one, I guess. Next. 15. All right. Next page. Oh yeah, good one. Okay. All right, 15. We're doing the indicated operation, so we're subtracting these two equations. So when I do that, I want to factor the denominators. So I know this is x plus 4 and x minus 4. And this one is x plus 4, x plus 1. So I'm doing, difference of squares on that one, and then x method on that. That's what I'm doing. So multiply by 4, add to be 5. It's 4 and 1. That's where I'm getting those. Okay. Now, I got to have a common denominator. Well, what part do they share? They share an x plus 4. Now the parts they don't share are x minus 4 and x plus 1. Remember, your memory just clicked with what to do. Okay, so what's the first one need? On top and bottom. The second one needs. Good job. Okay, so that gives us x squared plus x minus 3x plus 12 over that stuff. And then we simplify that, so that's x squared minus 2x plus 12 over x plus 4, x minus 4, x plus 1. And would that happen to be one of our answer choices? Yeah. That's all. Nope, not D. B. Sorry. All right. So, good question. In a minute since we've done that. Next.
That's everything.
17. Okay. Yeah, one of those complex fractions. Okay, this one's similar idea. Goes right along with 15. All right, so key to this is working the top part and then the bottom part as separate problems and then putting it together. So when I look at this 1a plus 1, I got to think about that 1, there, the second one, as a fraction. So I put it as 1 over 1. And I need a common denominator between those two, which would be a. So this guy gets an a and an a. So that's 1 plus a over a for the top part. The same thing happens on the bottom. Both of them need an a, so that's 1 minus a over a. When you divide fractions, that's the same thing as multiplying by the reciprocal. A. And then you cancel out these a's. You get 1 plus a, 1 minus a. Matches up perfectly to C. So getting a common denominator on the numerator, simplifying, and working it out, and then getting a common denominator in the denominator, working it out. Flip the bottom one, multiply. Okay. Next. 19. Give the equations of the horizontal asymptotes. Horizontal asymptotes exist when the degree of the top is less than the bottom, or they're the same. What are these? The same degree. There's got a squared on top and squared on bottom, so it's the same. The ratio of the leading coefficients is going to be your horizontal asymptote at y equals 4 over 5. If it were x plus 3 over x squared plus 5x minus 7, your horizontal asymptote would be at y equals 0 automatically. If the degrees match like these do, then it's going to be the ratio of those leading coefficients. It's going to be 4 over 5 or whatever numbers are in front of those. That's how you're going to get your horizontal asymptotes. Yeah, most of the things you're going to find are not.
So on a horizontal asymptote deal, if the degrees are not the same, well, automatically.
If the degree of the top is smaller than the degree of the bottom, then it's y equals 0. If the top is bigger, depends on how much bigger. Whether it won't have a horizontal asymptote if the top is bigger. It could have an oblique if the top is only one, like if it's cubed over squared, then there's an oblique asymptote. But if it's like fourth over squared, then it's neither of those. Don't have either. So like on 18 there, 18, the vertical asymptotes are going to come from the denominator of the simplified fraction. This one doesn't simplify any, so it just, it straight comes from the denominator. But so like this one, you would normally have, you would want to factor that if at all possible. And if I factor the denominator, I get 3 and x minus 3. The numerator does not factor at all. So that means my vertical asymptotes come from setting 3 x minus 3. Set the denominator equal to 0 and solve it. If I divide by 3, that goes away. X minus 3 equals 0, and that'd be x equals 3. So there's a vertical asymptote at x equals 3, which is A for that one. Vertical asymptotes are going to come from the denominator of your fraction, but you got to try to simplify it first, because you could have something like, maybe if you had x squared minus 4 on top, and then on the bottom you've got x squared plus 5x plus 6. You don't just set x squared plus 5x plus 6 equal to 0 to find the vertical asymptotes. You've got to simplify it first. So like this is x plus 2, x minus 2. And then the bottom part factors is x plus 3, x plus 2. And then those cancel out. So the simplified version only has an x plus 3 in the denominator. So your vertical asymptotes are x equals negative 3. That's the only vertical asymptote. You instead of having x equals negative 3 and x equals negative 2, you only have the x equals negative 3 because something canceled out.
So you would factor the possible.
You'd factor everything that you could and try to cancel something out if possible. If you're trying to find the domain, don't cancel. Domain, remember, has everything that's in the denominator to start with. Vertical asymptotes is after you've canceled stuff out. That's what you got to remember about those.
The oblique is the same thing as the vertical.
No. The oblique is when you have a numerator that's 1 degree higher than the denominator. So it'd be like something, if you had this kind of function, maybe you had x cubed plus 5x squared plus 6x minus 8 over x squared plus 4x minus 3. Okay, if we know that has an oblique because the degree of the numerator is 1 more than the degree of the denominator. 3 is 1 more than 2. So to find that oblique, you got to do long division. So what times x squared gets me x cubed? Be x subtract x cubed. Those cancel. That's x squared. And then that would be 9x minus 8. So then I would, what times x squared gets me x squared to be plus 1. Subtract. And then what happens after that really doesn't matter, because those cancel. And that's 5x minus 5. This, our oblique asymptote, would be y equals x plus 1. The remainder doesn't matter when it comes to the oblique asymptote. So the obliques are happening when the degree at the top is 1 more than the degree at the bottom. Some good questions. Next.
Yeah, I missed the formula about how to make those up.
I didn't write it on there. I didn't talked about that. Make a good grade. That's all you need to know. No pressure. Don't screw it up. Okay.
24 and 25.
All right. 24 and 25. Yeah, those are similar. Perform the indicated operation. Write the result using only positive exponents, the same variables that represent non-zero real numbers. So that part really doesn't matter. Positive exponents only is the thing that matters. So what you want to do is perform all other exponent rules before you fix the negatives. Okay. So the first thing I see is I got 28 over 7. Should just be 4. And then I have a to the negative 6 on top divided by a to the negative 14th. What's the rule for division in exponents? You do what with them? You subtract them. And then that would be b to the 2 minus 4, which equals 4a to the 8th, b to the negative 2. Now I fix the negative one. So how do I fix the b squared? Where does it go? Goes to the bottom. Change the sign of a negative exponent. Move it from where it's at to where it belongs. Or where it would change this. If it's in the numerator, which it is to begin with here, on our red part there, move it to the denominator, which would be C, the next choice there. All right. 25, same thing, it's just a little bit more work to do before we can fix stuff. Okay. So exponent rules, 4 distributes to both of those. So that's going to be, b to the 4 times negative 3 be negative 12 divided by 2 be negative 6. On the bottom, 4 times negative 8 would be r to the negative 32 over 7. So it leaves kind of ugly there. And then that's going to be r to the negative 1 over b to the negative 2/5. Then I'm just going to multiply straight across. So that I've got b to the negative 6, r to the negative 1, over r to the negative 32 over 7, b to the negative 2/5. Kind of ugly, but it's a problem just like what we just did. You got to subtract your exponents on the b's, negative 6 minus negative 2/5, r to the negative 1 minus negative 32 over 7. And I'm not in the mood to do that by hand, so I'm just going to do it with the calculator. Negative 6 minus a negative, how much? 2/5. Math, enter. Negative 28 over 5. That's what's on B. Negative 28 over 5. R's, negative 1 minus a negative 32 over 7. Negative 1 minus negative 32 over 7. And that's a really ugly decimal, so I'm going to make it a fraction. So it can be a really ugly fraction of 25 over 7. Which one needs to move? B. So it's r to the 25 over 7, b to the 28 over 5. Which would be C. The order of operations, exponents, multiplication, division, and then addition, subtraction. It works with the exponents as well. Next. Okay. Got a absolute value inequality. It's a less than symbol. So that means it's an OR problem. So I have 2x plus 8 is less than 9, or 2x plus 8 is greater than -9. No equal to mark on that. And then I'm solving each of those individually. 2x is less than 1. X is less than 1/2. Or, and then this one, 2x is greater than -17. X is greater than -17 over 2. So we got to think about that in interval notation. X's are less than 1/2, or they're greater than 17 over 2. Okay, so less than 1/2 or greater than 17 over 2. -17 over 2. No, couldn't be A. I actually don't think the right answer is on here. Because this is -infinity 1/2 union. And then this, well, actually it is. So, and this is from -17 over 2 to infinity. -17 over 2 is actually inside of that. So if it's going to stop at -17 over 2 and go up, and it's only going to go up to 1/2, that means that your answer choice should be D, I believe, for 30. Make sure that's right. Yeah. Because one interrupts the other. That's right. Greater thans are ands, less thans are, well, hold up. Greater than are ors, less than. That is an and problem. I am so sorry. That is an and problem. That's why it overlaps like that. Yeah, land of Gore. I taught you that. So let's do it a better way. It's an and problem. Remember with the and problems, we could do 2x plus 8 in the middle. Do that. And then that makes the problem a little easier to see what's going on. There's 17. There's the 2x. There's the 1. And then it's -17 over 2 is less than x is less than 1, which makes it more obvious for less than 1/2 that D is the right answer there. Thank you for mentioning that, Cindy. I screwed that up. Less than is an and, greater than is an or. And problems, you make a sandwich out of them. One of them is just the matching inequality. Then you go to the other end and put a less than symbol and change the sign. You get that. Or problems got to do like I erroneously did earlier. Write it as two separate problems. So greater than would have been an or. All right. Let's see if I can work another one right. $37. All right. Fun one there. Order set of data there. Introducing inhibitor into a culture. All right. Use the graphing utility to fit a logarithmic function to the data. Round your values to the nearest hundredth. 2 decimal places, what that means. Then use the function to predict the luminosity to the nearest hundredth after 20 hours. So we're going to find 20 and what goes there. All right. So with your calculator, this is what you should do. You're going to have a table, the x's and y values. Okay. So I'm going to hit stat, edit, and in list 1, I'm going to put all of those times. 2, 3, 4, 5, 8, 10, and 15. And then in list 2, I'm going to put those luminosities, whatever those are. Make sure everything's paired up the way it is in our table. And I think it is. Okay. Then I'm going to hit stat again. And then I'm going to hit second when I did that. I'm going to hit stat. And then I'm going to go over to calc. And I want to do a logarithmic function. So I'm going to go down here to, I think it's number 9 that we want. Because it's asking for a log. And every one of our answers has ln in it. Yeah, so we want ln reg. Logarithmic regression. If they'd said do a quadratic regression, we'd do number 5, the quad regression. If they said do a linear regression, we do, number 4, the ln regression. They said do a logarithmic, so that's ln. Remember, that's natural log, so that's why we're using that. Okay, so natural log regression, XList. This should be way yours is already set up. Shouldn't have to change anything there. And then we want to calculate that. So press down, calculate. All right, so it says round it to 2 decimal places. So the the problem should be 98.75 minus 32.66 ln x, which that tells us which one's the answer. A. We don't even have to calculate the 20 out of that. A should be the answer. Now, if for chance on the final, maybe they don't have the equation written there, they just have the 0.91 written there. How do you get that number? What you do is you plug in 20 for x. So with the calculator, you do 98.75. Whoops, let me get the 8. 8.75 minus 32.66 natural log of 20. And that's where, and they're rounding that to 2 decimal places, that's where the 0.91 comes from. So if by chance they don't have the equation, that they don't want the equation, they just want the answer, that's how they're getting the answer. So you get the equation, plug in the 20, and that gets you the luminosity, whatever that means, of the culture of luminescent bacteria. Glow in the dark bacteria. That's not so slow. Fun problem. All right. Good question. That's a little different regression than what we've done, but doable. Easy to do once you see it done. It's not a hard thing to do.
Few of them on here.
I just one in 100 there were several of those, but I just see one of those. That seems to be the only one I see. Let's see on the other page. No. It's the only one that's on there. Which one? 38. All right, 38. They give you the equation to deal with, so we're going to use it to help us in doing that work. One method for determining the time since an animal died is to estimate the percentage of carbon-14 remaining in its bones. The percent P in decimal form of carbon-14 remaining after X years is given by this function. So they give you an equation where E is the base, and then that big long decimal there is the exponent, and that X is in the exponent as well. Approximate to the nearest whole year the age of a fossil where there's 34% of carbon-14 remaining. So decimal form of 34% would be 0.34. So we set that problem up like this. 3 zeros, 1, 2, 1, X. How do we get rid of the E? Y'all remember? That's right. Natural log of both sides. Cancels the E out. We got natural log of 0.34 equals negative 0.000121 X. So I divide by that decimal. And that should give me how many years? So I just need to calculate that. Natural log of 0.34 divided by negative 0.000121. Sure that's the right number. It is. 8,915.78. And it said round to the nearest whole year, so that would round up to 8916. So B. The answer choice B. So they give you the equation, and then you just do from there. I will give you the financial formulas that you would need for 32, 35. You've got the equations in the problem in 35. Then 36, the problem, let's do 36 there since it's not there close. We'll go ahead and mark it. That way you've seen it. But I will give you those formulas. I'll write them on the board. That's what I'll do. So on 36, I believe is right. So radioactive decay rate is 0.175 annually. Determine the half-life to the nearest year. So 1 equals 2 e to the 0.175 t divided by 2. That's 1/2. Half-life, that's where that comes from. And then that's the same problem, just different numbers that we just solved for 38. That we just take the natural log of both sides. These cancel out, so we get 0.175 t. Natural log of 1/2. Work that out. So natural log of 0.5 divided by 0.175. Hold on. Did I misread the problem? Let me go back. I think I forgot to. That was in a percentage. So there's two zeros in front of that. Sorry. For some reason I thought they did that as a decimal. So 0.00175 is what I'm dividing by. So natural log 0.5. 0.00175. Because it was in a percentage, and you have to have the rate should be as a decimal. So then our and did it say it said decay? So that should also add a negative sign to that because it's decay. If it's growth, it'll be a positive percentage. And so you change your percentage into a decimal. So move 2 places to the left.
Gotcha.
And like on 38 when we worked it, we changed it to 0.34 instead of 34%. We're dealing with a much smaller number here. And then that would make that a positive answer of was it 396? What did I do with my calculator? 396 years. Yeah, A. The answer choice A. The decay means the negative part, and then when you change the rate to a decimal. And then, but that I would give you that formula. I'll write it on the board so that you've got it. That's the same formula as principal e to the RT. The PERT formula, the continuous interest formula, it's the same one. But we're talking about what we talking about there. Half-life of some isotope, whatever an isotope we're dealing with in chemistry or biology or whatever we're doing. I don't know what we're doing. Isotopes. Mm-hmm. Yeah. That in 396 years, this isotope would be half of it decayed away. That's what that means. That half-life would be how long it would. Yeah, sure. 35 has got the function in the problem. We just got to figure out what they want us to do with it, and that's the hardest part. The solving it's not that bad. It's just figuring out what they want you to do. Sometimes it's the most difficult part. All right. So size P of a small herbivore population at time T, and it says that time is in years, obeys this function. So they give us this function. P of T is equal to 500 e to the 0.16 t if they have enough food and the predator population stays constant. After how many years will the population reach 1,500? So the population is P, or P of T. So when is 1,500 going to be the population? If everything else stays the same. So we set that problem up and we solve it. So it's just like the problems where we did, when will my bank account be worth $3,000? Or, when will my bank account be worth a certain amount of money? It's the same problem. We're just talking about some sort of animal this time. So divide by 500. 3 e to the 0.16 t. And then what do we do? How do I do that? Perfect. So natural log of 3 equals 0.16 t. Now what? Got to get t by itself because I'm looking for how long. Divide by the 0.16. So natural log of 3. Close the parentheses, divided by 0.16. 6.87 years. which would be A. Oops, too far. Hope there's a lot of those. They're easy. 2 steps, really. Once you get the problem set up, it's 2 steps. You kind of got a little cluster of about 3 or 4 there together. Makes it work out pretty nice. Yeah. Next. $39 and $40 should be pretty straightforward. 39 is RREF. 40 is a little bit more difficult because when you got, let's look at it, because I'm going to leave you hanging on it because that's the hardest of the systems of equations. These are the hardest because they don't have enough equations there for you to do. What's happening is you've got this other equation so that when you do your matrix, it would be 1, -5, 1, 20, then 5, -1, -1, 10, and then it's all zeros on the bottom row. So that's infinitely many solutions. And they're saying solve the system in terms of arbitrary variable x. So that means you want x in all your answers out of that. So you've got 2 equations to deal with. X minus 5y plus z equals 20. And then you've got 5x minus 1 minus y minus c equals 10. This one's a little difficult because you've got too many variables going on there. I wonder what it would do if I went in my calculator. Let's go ahead and put that matrix in the calculator and see what it does. If it'll simplify it any for us. I don't think it will, but it might. So I'm gonna put 1. Did it? -5, 1, 20, 5, -1, 1. Oops, that's another -1. 10, and then all zeros. All right, and then you ran RREF on that. Yeah, get that done. Math enter. Is that what you got? Okay, I want to make sure I didn't rush through. All right, so it did simplify a little bit. It gets us. Copy that. Gets us this equation turns into x minus 1/4 z equals 5/4. And we can take that problem and get z by itself. By subtracting x, -1/4 z equals -x plus 5/4. And then multiply everybody by -4/1. Or -4. So there's z would be 4x minus 5. So our ordered pairs are x, and then the z is 4x minus 5. Which that already tells us the answer is A. But if we took that second equation, it tells us y minus 1/4 z equals -15/4. I can get y by itself pretty easy. And then I'm going to plug in what z is. Z is 4x minus 5. So that's going to be x minus 5/4 minus 15/4, which is x minus 20/4, which is 5. And that's answer choice A. That's really the most difficult of the system because 41 you could do. 42 should not be on there. So you could forget 42. It will not be on the final. 42 will not be on the final. 42 will not be on the final. That's one of those standards they took out between last spring and here. And I mean,
Just trying to figure that one out.
yeah, I forgot to tell you to throw that one out. That's one of the things they took out of the course between last spring and here. $43 could be done in the calculator. 44, you got a 2x2 matrix and a 2x2 matrix. Set the corresponding parts equal to each other. It looks like it's really hard, but it's not. Because you got x plus 3 in the top left. What's the top left of the one it's equal to? So you just set it up, x plus 3 equals 5, and solve it. Be x equals 2. And then the y is in the top right, y plus 4. What's in the top right of the other one? -4. So you just set that up. So that'd be y equals, -8. And then the k is in the bottom right. So, k should be equal to the bottom right of the other one, which is -9. You get all your variables there. So it's just corresponding pieces of the matrix put together. So there. 45, they give you, they tell you what to do. I mean, straight up tell you exactly what to do. They say a triangle has vertices, corners, x1, y1, x2, y2, x3, y3. So 3 ordered pairs. Has an area equal to the absolute value of the determinant, or D, where that's our formula. Okay. So for 45, they've given us ordered pairs 1, -4, 1, 5, and 6, -1. So we're going to take 1/2 times the determinant of 1, -4, and that third column is all ones every time. And that's a 3x3 matrix. And I'm going to find the determinant of that. Use my calculator. So, second matrix, edit. I need a 3x3 that matches those. So 1, -4, 1. 1, 5, 1. 6, -1, 1. And then to find the determinant of that, I hit math, or excuse me, second matrix, and go over to the math menu, get the determinant of matrix, put that in A, and then I take half of that. Math, enter, and its area. Area is always what kind of number? Positive, because it's a measurement. Okay, and that's where they're saying up there in the instructions, it says the absolute value. Absolute value is always what kind of number? Positive. So we're going to change that to a positive 45/2, which would be B. What this is the area of a, you might remember the formula for area of a triangle, base times height, 1/2 base times height. The determinant of that matrix is the base times the height, is what that does. One of those weird things that a matrix can do for a triangle. You can actually do larger figures, but the matrix gets much more complex when you do that. Triangles is a pretty good application of it in our course. Okay. Next. 47 is just like the problems from the lab, just like the problems from the test. They've got the graph already drawn for you. They're telling you what the equations they used were, the inequalities they used. They went in and drew it for you. That's going to be how it will be. And then all you've got to do is take those ordered pairs and put them in there for the f, that objective function there. And it asks you to find the maximum, so the biggest answer. If it asks you to find the minimum, you find the smallest answer. .48 is an inverse. You put that in the calculator and tell it to do the inverse. So I'm going to matrix, edit. So 3 by 3, 1, 1, 1, 2, 1, 1, 2, 2, 3. And then tell it which matrix to find the inverse of. And then the inverse button is right there. The one that's highlighted in red, right underneath the math button. Hit enter. And there's the inverse matrix. -1, 0, -1, 1, 0, 4, -1, -1, -2, 0, 1. So it's A. That one. 49, you've got a couple of matrices set up there. How many female students are in the College of Business? How many male students are in the College of... All right, so the first, looks like a matrix, but it's really just a chart. The percentage of students in each category is given by the following. So, the first question is, how many female students are in the College of Business? So what percentage, how many females are there in the freshman class there are 430? 20% of 430 for the business. Get that number. And then do the same thing for sophomores, 20% of each of those values. And then really you could multiply these, you could actually multiply these two matrices together, and get the answers. You just have to know what you're looking at. That's a very difficult thing to explain. The easiest thing to do is just find the percentages for the freshman, sophomore, junior, senior, percentages for the females, add all that up. And then for the second question is, how many male students are in the College of Arts and Sciences? So you do the 60, 50, 40, 70 for the male students and add all those up on that for number 49. What I'm saying do is take for the College of Business, you're taking 20% of 430, 40% of 550, 30% of 850, 10% of 630, and adding those all up. And that gets you the females. And then you would take arts and sciences, you take those percentages times each of the male students in each class and add those up. And that would get you the correct numbers there. Number 50. On the males, you take these percentages that are in the arts and times, for the freshman, 760 times 60%, 50% times 750, 40% times 610, 70% times 480, and add all those values up. And that's going to get you the number of males in the arts and sciences. Number 50, a little bit more difficult problem maybe. It seems innocent and small enough, but there's a little work to do there. You got to remember how to take a determinant without the calculator to do 50. That's why I want to go over it. It's a 2 by 2. Remember, you cross multiply and subtract. Negative 2x minus 5 equals negative 7. And then solve that. It's simple enough once you set it up. But if you don't know how to do a determinant for a 2 by 2 without a calculator, you're stuck.
Okay.
So cross multiply. 2 times x is 2x. Negative 2 times x is 2x minus 5 times 1. And then that should be equal to negative 7. And you solve it from there. Okay.
On number 1, would you put the 5 in for x on each one of those to find out which can have true?
You would need to check to see which one 5 fits into in the inequalities, and that'll tell you which one of the problems to plug it into. So 5, is 5 less than 1? No, so you don't use that. You don't use 9x plus 1. Does 5 work in this inequality here? Because it's equal to, and that's got 5 less than or equal to x less than or equal to 10. 5 does work in that one. So that you're going to plug the 5 in there.
That's what I was doing.
And that'd be 25.
I was putting 5 into x first.
Yeah, you got to find which one to plug it into.
Okay.
So which one is true? Which one of the inequalities is true for that x value? And then use that piece of the piecewise that goes with that.
I was doing it right. I was just ahead of myself.
Yeah, you were plugging it in too soon into all of them instead of just one of them. Because you should only be using one piece of a piecewise at a time. Any others? 2. All right. You got a graph, and it goes. It's got a y-intercept of 0, and looks like a slope of negative 2 because it's going down and to the right. I could go down to right 1, and the x value that it stops at is 1. So it looks like the left side there, the top equation, A and B have the right equation, negative 2x. And they both go to the same spot there with the x is less than or equal to 1. Because that's where I know that this tells me that filled in dot tells me that there should be an equal to mark on that part. Okay. And then the fact that dot that dot that's inside that box, that it's filled in. That tells me there should be an equal to mark on my inequality. Notice how this dot up here is empty. So that tells me there's no equal to mark on the second inequality. So I've narrowed it down to A or B because of the negative 2x being the equation. Because it had a y-intercept. This line right here, that line that I'm following right there, that line has a y-intercept of 0 and a slope of negative 2 by just inspecting the graph. And then this one has a slope of, looks like up 1 over 1. So a slope of 1. Is the y-intercept 2 on it though? No, because it doesn't touch the y-axis there. If I kept that line going and went down one, over one, down one, left one there to keep that slope going, where's it going to hit the y-axis at? 1. So that's why B would be the correct answer for that one. Because it has the right parts for the pieces, the correct inequalities for those pieces, with the equal to and the not equal to marks. And then domain covers up everything, range. You see the lowest value is at -2, the highest value, it keeps going on up forever. So that would be a good way to tell as well. That's the only one with the correct range even out of that. So really by inspection is how you would do number 2. Not really a better way to do it. I'm sure there are plenty of other ways, but there's not a better way, I don't think. Any others? All right. So test is next Monday night. I've got the 140 test that's before you guys. It'll start at 4, so they will not be done until 6. Okay, so don't come in before 6 because I'm sure I will have 1 or 2 working the full 2 hours there. So don't come in until 6. I'm going to try to start as soon as we all get in here. Okay, I don't want to. So let's say we're going to start the test at 6:10. That gives them time to get out. You guys time to get in, get settled, and we'll start at 6:10. You'll have until 8:10, 2 hours to do it. Make sure you got your calculator charged up, batteries in it, that sort of thing, pencils. I don't know of anything else that you really need. It'll be on a Scantron card, so make sure you got a pencil to mark those. To figure out what you need to make on the final, Darren asked that earlier. So you take your current grade. I don't remember what it's called on there. Pre-final average or maybe whatever. I don't know what I put. Is that right? Current grade. I did right. Current grade. Take your current grade, and you got to have a C for this count, right, towards your degree. So a C is what score? 70. Okay, so you take 70 times 2, right? Hold on. Let's see. Current grade. From current grade times, you got to multiply it by 0.7. And then 0.3 times x minus that, or plus that, equals 70. That's how you want to do it. Okay, this is your final. Okay. So, for example, let's say my current grade is an 83. So I'd have 0.3x plus 83 times 0.7 equals 70. I'm going to take 83 times 0.7, 58.1. So that's 0.3x plus 58.1 equals 70. We'll subtract that to get x by itself. So 0.3x is equal to 70 minus 58.1. 11.9. And we'll divide that by 0.3. So I need to make at least a 40. on the final to keep a C. So you take your grade and you work that same equation. That'll tell you what your minimum score is to make a C. If you want to make a B, instead of putting it equal to 70, you put it equal to 80. If you want to make an A, put it equal to what? 90. Okay. So that, and you can solve that same equation that way. And that'll tell you what you need to do at each level on the final to get that desired score. Guys, if there's something comes up,